Good morning. Today I am doing 3.7 and 3.8, which is on complex numbers. Because the square of any real number is non-negative, a simple equation such as x squared equals -4 has no solutions in the set of real numbers. To handle this situation, mathematicians invented an expanded system of numbers, the complex number. The imaginary unit I, defined to be a solution of the equation x squared equals -1, is the basis for this new set of numbers. All right, so I is defined as the square root of -1, and I squared is -1. Know those two things, okay? If we need to take a square root of a negative number, such as here, square root of -b, what we could do is separate this and rewrite it as the square root of b times the square root of -1. Square root of b, there's nothing we can do with it, so we're going to leave that as square root of b. And the square root of -1, well, we just said that that is I. And then we write it as I square root of b. I like to put the I first because if you have it back behind it, sometimes they get real close together and you're thinking, is that negative, or is that I underneath the radical or not under the radical? Don't know. Up here, I know for sure that it is not underneath the radical. So let's take a look at the square root of -25. Okay, so I could rewrite this as square root of 25 times the square root of -1. Square root of 25 is 5. Square root of -1 is I. So that becomes 5i. Okay, so square root of -80. We can simplify this like we have other problems, okay? So that 80 is really 16 times 5, and then times that -1, okay? So square root of 16 is 4. Square root of 5, I can't do a thing with it. Square root of -1 is I. So this will be 4i square root of 5. All right, these numbers are complex numbers, and they are based on multiples of I to real numbers. A complex number is any number that can be put into the form of a plus bi. This is standard form. We always put our real part first and our imaginary part behind it. Okay, let's see here. So if I had something that looked like -4 plus 6i, this is my real part, this is my imaginary part, okay? So you need to keep in mind real part first, imaginary part behind it. Okay, adding and subtracting complex numbers. So if I had something that looks like a plus bi plus c plus di, I could rewrite this, putting my real parts together and putting my imaginary parts together. And here's my real parts. I'm going to factor out the I out of the imaginary parts, and then I could just add the coefficients to my I's together. So let's see how this works. So if I were to do this the longest way possible, rewrite it, go 4 plus 5, those are my real parts, plus, then I'll have a 3i plus 9i, okay? That'll give me a 9 here, plus, then I'm going to factor out the I back here, and I'll get 3 plus 9 times that I. So this will give me 9 plus 12i. Okay, but notice we could have just added together those coefficients right there. 3 plus 9 gives me that 12. All right, same process basically works for subtraction, but I need to be careful to subtract all of this part back here, okay? So I am going to add the opposite. Most people remember to subtract the first term, but the second term they forget. Okay, then I'm going 9 minus 5, well, that gives me 4. 8i minus 3i, that'll give me a 5i, and there you go. That's it. Okay, let's take a look at some more problems. Multiplying with complex numbers. Multiplication of complex numbers is performed the same way as multiplication of polynomials using the distributive property, but keep in mind that I squared is -1, okay? All right, so I got a monomial times a binomial. I'm gonna distribute this over. And I'll do this one the longest way possible first. So this is gonna be 4i times 3. Then I'll have a minus 4i times 5i. Now, I'm going to put my coefficients together, and I'll have 4 times 3 times I. So that gives me a 12i. Then back here, put my coefficients together, 4 times 5 times I times I. Okay, 4 times 5 gives me 20. I times I is I squared. Well, didn't we say I squared is -1? Okay, so this really becomes 12i minus 20 times that -1. Okay, so, or minus 20 times the -1. So -20 times -1 gives me a positive 20. So now I have 12i plus 20, but this isn't in standard form. Our real part has to be first. So we have 20 plus 12i right there. Okay, so that's the longest way possible here. This next one, same type of problem. I'm going to go 7i times 2. Well, when I did this part up here, I just multiplied the coefficients together and tacked that I on. So this is going to be 14i. Then I'm going to do this part here. 7 times 9 gives me 63, and that's an I squared because I times I. Well, didn't we say I squared is -1? So what I do is I cross this out and change that sign. Okay, so now put it in standard form. So I have 63 plus 14i. Next one, binomial times a binomial. All right, so let's do this here. 7 times a -2 gives me a -14. 7 times a -5i is going to give me a -35i. -3i times a -2 is going to give me a positive 6i. And a -3i times the -5i is going to give me a positive 15i squared. Okay, so now we have to combine like terms and clean this up. Well, I squared is -1, right? So I'm going to cross that out and change that sign, because that's the same thing as multiplying by a -1. These two guys here are like terms, and these guys now are like terms. Okay, so -14 times the plus the -15 is going to give me a -29. Combine those guys, give me 29i. And there you go. Okay, next one. Same type of thing, okay? So I got 30 minus 35i plus 24i minus 28i squared. I squared's -1, so I'm going to change that sign. Then I'm going to put together like terms. Those guys are like terms, and these guys are like terms. So 30 plus 28 back here is going to give me a 58. And then the -35i plus 24i is going to give me a -11i. And that's it. Okay, so you need to be careful when you multiply square roots of negative numbers. The product rule for radicals only applies to real numbers. When performing operations with square roots of negative numbers, begin by expressing all square roots in terms of I first. So I need to write this as I first. So this is going to be a 5i times 2i, and I'll get 10i squared. I squared is -1, so that becomes a -10. Okay, so let's take a look at this exact same problem right here. Now, what if you had put these together under one radical, okay? And you said, okay, that is -25 times -4. That gives me -25 times -4 is 100. Square root of 100 is, square root of 100 is 10. Notice you got a different answer here. So to make sure everyone gets the right answer, we need to express it in terms of I first, okay? You cannot do this here. It needs to be expressed in terms of I first. So this one would be I square root of 3 times I square root of 5, which would give me an I squared square root of 15. All right, I squared is -1 square root of 15. You can write it like that if you want, or you could say negative square root of 15. Either way works, okay? All right, conjugates. It is possible to multiply imaginary numbers and obtain real numbers, okay? So when we multiply by a conjugate, remember that if we start with something like this, the conjugate is the exact same thing, but a different sign, okay? Exact same thing, different sign. All right, so the conjugate of 4 plus 7i would be 4 minus 7i. All right, since it's the exact same thing with opposite signs, I know I'm going to lose my middle term, so I'm not even going to bother trying to find that. Well, most of the time. I'm going to do it on this one here so you can see. So 4 times 4 gives me 16. 4 times -7i gives me a -28i. 7i times 4 gives me a +28i. 7i times a -7i gives me a -49i squared. Okay, I squared is -1, so I'm going to change that sign. And let's put together like terms here. These guys are like terms and those guys are like terms. Well, those guys are opposites, so they're gone. So now I have 49 plus 16 there. So that's going to give me a 65. So notice we started out with imaginary numbers and we ended up with a real number. Now, when we multiply by conjugates, remember that middle term drops out. You can save yourself a bunch of time. And just like radicals, we cannot have an I in the denominator. So we have to multiply by the conjugate to clear it out, okay? So this one's breaking a rule. I'm not allowed to have I there, so I'm going to multiply top and bottom by the conjugate. Okay, multiplying by 1, it's not going to change the value. I'm going to put some parentheses around things here. All right, then I usually start on the bottom. So 2 times 2 gives me a 4. Then this is going to give me a -25i squared. I squared is -1. So down here, I have a 29. Okay, that's my denominator. Then up here, that's going to give me a 14 plus 35i plus 8i plus 20i squared. I squared is -1. All right, put together like terms, and we will get, what is that? Trying to figure out where I am here. It's 20, so 14 minus 20, that's going to give me a -6. Then those guys together is going to give me a plus 43i, and that's going to be over our 29 right here. Okay, this is pretty good, but we have our real and our imaginary mixed together. So the best way to write this answer is -6 over 29 plus 43i over 29. Okay, this is my real part, this is my imaginary part. They aren't mixed at all. Okay, let's take a look at this next one, which is a little tricky. Okay, isn't this right there, my denominator, really 0 plus I? Okay, so what would the conjugate of that be? Well, it'd be 0 minus I. Okay, so I need to multiply this here by top and bottom by negative I. Put parentheses around this. We're going to distribute. That'll give me a negative 7i, and this will give me a positive 4i squared. Then I times negative I, that is going to be a negative 1i squared. Well, I squared is -1, so I'll change that sign. That gives me a 1 down here. Okay, I squared is a -1, change that sign. So now I have -4 minus 7i, and that is over 1, so I do not need to write that part. Okay, now we're going to do cycles of I. Okay, I to the 0 power. Anything to the 0 power except for 0 to the 0 power is 1. Okay, anything to the 0 power. Anything to the first power is itself, so that's going to be I. I squared, well, our definition in the very beginning said I squared is -1, so here you go. I cubed, well, isn't I cubed really I squared times I to the first? If we look over here, we have a rule that says we can split it apart and rewrite it like this. Okay, so I squared up here, we said it's -1. I to the first power, we said is I. So I have -1 times I, so that equals -I. Down here, I to the 4th power. Well, isn't I to the 4th power really I squared times I squared? So that would be -1 times -1, which is a positive 1. Okay, all right, I to the 5th here. That's really I to the 4th times I to the 1st. Well, notice every time we multiply by I to the 4th, it is 1, right? So that would be 1 times I to the 1st. Well, that's I, so 1 times I is going to give me I. Okay, I to the 6th. Well, we're back to I to the 4th. We can always rewrite that as a 1, and I squared is -1, so 1 times -1 gives me a -1. I to the 7th. Well, I to the 4th, which is 1, I squared, which is -1, times I. Okay, 1 times -1 gives me a -1 times I gives me a -I. I to the 8th. Well, that's I to the 4th times I to the 4th, so 1 times 1. That'll give me a 1. Now notice our pattern here. 1i, -1, -I, 1i, -1, -I, 1, and that goes on and on forever. So what if I were to ask you, like, what is I to the 39th? You know, you could write all that out and figure it out, but to save ourselves some time, we have this formula right here that says the value of I to the n can be found by dividing n by 4. So take whatever your exponent is up there and divide it by 4. If the remainder is r, then I to the n equals I to the r. Now we're dividing by 4 because remember, every time we did a 4, it was 1. Okay, so take 39 and we're going to divide it by 4. So 4 times 9 gives me 36, and I have a leftover 3. So my remainder is 3. So I to the 39th equals I cubed. I take whatever my remainder is, that is my r, and that goes right there. Then we said I cubed, if we come up here, is negative I. And there you go. Okay, let's try this last one here. So I have 25 divided by 4. So it goes in there 6 times. That's 24. And this time I have a remainder of 1. So I to the 25th equals I to the first power. And if I go up here, I to the first power is I. All right, there you go. Hope you enjoyed. Bye.